Good morning, everybody, and welcome to the last day of Code4Lib. We made it. Yeah, absolutely. Let's stick this landing, okay? In keeping with, I think it's a recent Code4Lib tradition, we have a message from our wonderful Social Activities Committee Chair, Becky Hughes. 1 second, please.
Good morning, it's time to wake up, it's a new day. Good morning to you. Good morning. Welcome to the last day of the conference, and I hope you have a good day and safe travels back.
All right, thank you, Becky.
Well,
So, for those of you who are used to returning your lanyards at the end of the conference, you get a prize. You get to keep your lanyard this year. So congratulations. Also, reminder, your Code4Lib lanyard is good for free admission to the Heinz History Center. So if you're in town till later today or till tomorrow, please take advantage of that. I also want to shout out the local planning committee's Matt Strauss from the Heinz History Center for making that happen. So, thank you, Matt. The community support volunteers for this morning are Bobby Fox and Eric Pettiplace. They are located in the back of the room. They have the zebra stripe lanyards. You guys could stand up, wave a little bit. There they are, right there, middle aisle. Thank you for doing this. We really appreciate it. So let's get to the closing keynote. Our closing keynote speaker is Allison Langmead. Allison Langmead holds a joint faculty appointment between the Dietrich School of Arts and Sciences and the School of Computing and Information at the University of Pittsburgh. She teaches and researches in the field of digital humanities, focusing especially on applying digital methods mindfully within the context of visual and material culture studies. With that, I'd like to introduce our closing keynote speaker, Allison Langmead. There's your HDMI over here.
Excuse me, guys. Wonderful. We good? Can everybody hear me? Thank you all for coming out on what's becoming a quite stressful week, I believe, certainly in Pittsburgh, around the world. But I'm really happy to see so many of you here today. As introduced, I'm Allison Langmead. I work here in Pittsburgh, and I'm here today with a talk entitled Programming Mentorship. It's as close to a pun as I can get. We'll get through what it is that this implies by the end. And I want to emphasize before I start that this could either be the world's shortest keynote, or if I get off topic, which my students tell me I do all the time, I won't get to the end of my slides. I'm hoping that it'll be just right, because I would really like to have a conversation about the ideas I present here, because I want to emphasize 110%. I do not come here intending to bestow wisdom, although that's what I guess a keynote's supposed to do. I come here with a request and actually an admission of a certain amount of failing within the academy to do what I think needs to be done with mentoring programming as an activity. That's a cultural critical activity. That's an empowering activity. So again, here are some ideas that I've had about the way programming itself can be distributed throughout our society, frankly, and come with a request for libraries in particular to help out in the process, because I don't think for structural and other reasons, I think the Academy is not showing itself able to do this on the teaching side, and more collaboration with libraries is absolutely essential, both public and academic libraries, by the way. I have very little experience myself with public libraries. I have some with academic libraries, both as a teacher in an iSchool and also, of course, collaborating with my absolutely fabulous colleagues at the ULS at Pittsburgh and beyond. But I sort of mean across information institutions. All right? So with that, what is programming? It's sort of like saying, what is coding? What is programming is a big and large and complicated question, but for today, I'd just like to talk about it as meaning making with a computer. Computers are objects that participate in our intentional structures. They help us produce and construct and play with our ideas and our narratives. And so for today, I hope you will join me at least in considering that if you are performing meaning making with a computer, you're programming that computer. I will put it to you today that programming is always done within a context that's sort of self-explanatory in its own way, but really critical to the issues that I'd like to bring up with you this morning. The thing about thinking about computing and making meaning within any particular given context is that when you're focused on a context, concrete goals are in sight. You're trying to do something. You're trying to make something. And only one of those contexts is the context of computer science. When one of the case study examples I'll be drawing upon this morning is that I worked at Pitt with our computer science department to modify the intro to programming in Python make a humanities recitation. It runs now at CSO 13, I believe. Send your students. It's a good course. I'm not here in any way to disparage the course, but what we tried to do and by we, I mean myself, my colleague Matt Lavin, and my colleague Ben Miller, both from the Department of English now at Pitt. We tried to sort of tweak and change the context around which we were talking about computing. So, this is a statement it's an assertion, which I would like to discuss with you guys today, which is that programming can actually be learned without explicit mentions of the scientific concerns of computer science. My continuing joke about this is that the Fibonacci sequence is a delightful mathematical sequence. It's a series, it's really interesting, it's lots of things found in nature. But unless you actually need to use the Fibonacci sequence, you have to do a lot of work to figure out how that very common introduction to computer science sort of algorithmic looping procedure can help you in, say, working with German conceptual art in the 1960s. Programming pedagogy, I think it goes without saying, can help people solve their problems or spark their creativity. And I've written about this a little bit, so what I'm going to talk about next is this paper that I wrote with my colleague David Birnbaum at Pitt from Slavic, digital humanist of long pedigree, about task-driven programming pedagogy in DH. And I also need to make one more caveat here, is that I'm a digital humanist. I work within the context of the digital humanities, but back in the slide where I said that only one context for programming is computer science, I could have also said only one context for programming is the digital humanities, or art history. I'm an art historian. So I'm not putting computer science necessarily aside as any sort of extra special context, except for that is the context that is usually used in introduction to programming courses. So David and I try to argue how could a pedagogy of programming be applied successfully within particular contexts? And we give an argument in the paper for how it could happen in the abstract, and I'd like to talk about basically today how I wonder if it could actually work better in the information services, library, and maybe even archival context, who knows? So what is it? We argue that task-driven, context-focused programming pedagogy is narrowly focused on what people actually want to do. It's less abstract. It's task-driven. You're doing what needs to get done, and this could either be that the students come in proactively with tasks they need to solve, or you offer that to them. You offer tasks to them, but you offer them tasks within a context. It's at this time I've only gotten off topic twice, so far so good. At this point that I would like to mention that part of the reason when you guys so very kindly, and thank you all, asked me to come and give this talk, one of the talks that I had been talking about in my lab presenting came from a tweet that I saw when I was attending DLF this year. And it was yet another conversation about teaching introduction to programming in I believe it was library, but that hardly matters. And it was clearly, it was a great class. There was a lot of good mentorship, we'll get there. But the actual things that were being taught were abstract. They were completely mathematical and abstract in the same way that computer science usually is. And that's amazing. And it's wonderful. But I got the impression from the photograph that a lot of people just needed to get something done. They either wanted, and to make matters sort of slightly worse, everybody in the room had something slightly different that they wanted to get done, right? And so there's one way you can teach that pedagogically. If you have a whole bunch of people in a space, or not a whole bunch, say 10, because that's the sort of size of a class that I am pitching here. If you have 10 people who all want separate things in a class, then one way to deal with that is to go up one level of abstraction, right? And teach them a whole bunch of high-level concepts that will eventually apply to all of them. And that is what I was seeing in this particular example. And I do it all the time. But I wondered, having worked on this with David, what if the work could be done by some group, right? To actually try to do smaller, mentor-driven conversations where people had much more similar tasks so that we didn't have to move up to one level of abstraction. We could stay at the level of the task and really work through what's going on. So that's where this task-driven and doing what needs to get done comes into play, because part of the way that this alternative, well, I don't even really want to call it alternative, the way I'm pitching really effective, empowering programming pedagogy could work would be to actually target specific populations. And then, as in this case, it would much more effectively be mentor-led. And the opposite of mentor-led is, I don't know, guru-led, right? Something abstract. Mentorship, I'll talk a lot more about what I imagine mentorship is. This is something that's been talked about in the digital humanities a lot. It's something, actually it's a buzzword in the academy anyway, right? That professors are actually mentors. And some of us are and some of us aren't. They are different jobs, however. But the programming pedagogy I'm arguing for today is narrowly focused, task-driven, and mentor-led. There's someone who's actually there alongside you, not over you, offering you help, specific help. The metaphor we use in the article is language acquisition, and as an art historian, and David teaches Slavic languages and literatures, this is, of course, his, but I bought into it the second he pitched it to me. Insofar as programming also involves languages, sort of syntax and semantic-driven ways to help a computer make us help a computer help us make meaning. He pointed out that we've actually changed the way we teach languages just to humans since the 80s, and there are some parallels between the old way to teach languages and what I guess I'm happy to call the old-fashioned way to teach computing, and the new way we teach languages, and the proposed way to teach programming. So the old model for teaching human languages to each other is grammar and translation. I'm a Gen Xer, pretty rock solid. I took, I guess, 4 or 5 languages in the course of my training to become an academic, and this is a very familiar tradition to me. You're taught a language by being taught the rules of the language, grammar and translation. And what that does to language in the main is until the human being goes ahead and incorporates all that and turns that into actual spoken speech, is that you sort of develop skills at a grammar and vocabulary level, and what you're studying is actually the structure and the vocabulary of the language, building up a heuristic so that you can speak it, but that isn't the primary, that isn't the story told by that pedagogy. The story told by that pedagogy is that grammar and vocabulary are your objects of study. The newer model, which I see happen, and I know for a fact that students find pros and cons in this, so let me be clear, this isn't a magic bullet by any stretch of the imagination, is to teach oral proficiency. So students are pretty immediately thrown into contexts that they might find themselves, family life, shopping, tourist activities for sure, and taught to inhabit a situation in which the known and unknown sort of work together as you try to get your messages across. So the focus is actually communicating your thoughts rather than studying the language. Now, studying the language is something that academics absolutely do. Studying languages is a fascinating thing. But when you're actually taking a class to learn a language, unless you plan to become an academic studying that language, you're usually focused on this task. How do I get along? How do I communicate with people? And so they've shifted the way that they teach, or they have theoretically shifted the way that they teach languages to this sort of more communicative task. I certainly see it in the way my children are being taught languages now. So we ask our question, it's a metaphor. So we ask questions like this. When we're offering programming instruction to anyone, are we offering them as programming languages as the object of their study, which again honestly could be the case if you're in a computer science department learning for computer science purposes? Or is it that the people in the room just need to get something done, or something done in their own domain? As one more example, programming texts themselves point to this, which is one reason why teaching programming in different ways can be difficult. Old school traditional CS textbooks read a lot like grammar and vocabulary language textbooks, where you're taken through the data structures and the very sort of traditional syntactical methods for producing logic within a programming system. There is another style, and David is a big fan of these. There is another style of CS book that's more of a reference work, the cookbooks, where you go and you look it up. Now you can imagine that we're using books here as if that's where people learn programming. I could make the same argument for Stack Exchange, right? If you want to go and find out what you need to do, you go and you look up a specific task and you find out how to do it. And there are pros and cons to this, right? People putting in patches that have eventual security bugs because they don't have fundamental principle knowledge. But I'm going to argue that comes second, not first. All right, doing good. Is there a role here for libraries or information services of all types? I think yes, of course, or at least I'm asking. So, one of the things that I think about programming is that it is absolutely an academic enterprise at the computer science level. I think that studying languages, producing new operating systems, producing new ways to, more efficient ways to compile, all of these things are absolutely essential to our computing infrastructure. What I'm arguing here today is that there's a huge, large community, though, who are interested in learning how to make meaning with computers who don't have those goals in mind, and how do we actually serve those groups? I personally think it happens to be sort of a culture critical thing, and it's something that everyone should have the opportunity to do. So finding other contexts in which to really get to grips with what needs to be done is essential. For me, learning how to apply computation in the context you wish to apply it is a question of empowerment. And I will say, I'm talking about programming here today as meaning making with a computer. And so, of course, I mean being able to pick up Python and do what it is that you want to do with Python or Java or C++ or whatever it is that, whatever particular syntactical structure that we're talking about here. But in the main, I'm also could just as well be talking about Excel, right? Certainly Excel being one of the most powerful programs that actually is on a computer, in my opinion. I say that to my students all the time, and they roll their eyes, and then they start the digital humanities, and they go, oh. Because the way that you actually pick up these tools matters, and in context, they allow you to get the computer to help you make meaning, and that is what we're trying to do here. So I consider it a question of empowerment. This is a critical last metaphor from David, which is that this is like asking, in terms of empowerment especially, it's as if we should consider that everybody can cook, he says, and we shouldn't be trying to teach them to cook as if we're starting on the road to getting them to understand and actually produce fusion cuisine. We need them to be able to make a meal and put food on the table and get done accurately and effectively what it is that they need to get done, because they are hungry. There are people who consider computers to be very, very foreign. There are some who know that they can help, and then there are some who don't even know what it is that they can do. And learning these things, I feel, is absolutely sort of culture critical. So if you've been following, which I actually see so much attention, thank you so much. The question here is, are you asking us to run classes of 3 people each that take an hour where there's one-on-one instruction forever? No. Well, yes, if you'll do it. But I have some ideas at the end about how this can actually be structured into something that is relatively repeatable. But I do know that it is a big ask, right? What I am asking is for a lot of attention to be paid in an area that doesn't have as much attention. And I'm hoping that by framing it as a question of empowerment and culture critical importance, that we as a group, I'm not asking to delegate this responsibility, I'm asking for partnership, that we can find a new way to actually spread and focus on a task-driven pedagogy for programming that can amplify understanding of what it is that computers really are and what they really can do. Thing is, I argue that contemporary libraries and information services actually know context better than most other sectors. Between liaison librarianship certainly in academic libraries and embedded librarianship all over, librarians have gone out into the world and actually learned what it is that people know and do. And so in many ways, I actually believe that librarians are the best people for this task. I'm not just asking for asking's sake. The way that librarianship has changed even since I've got my high school degree has been incredible, and that has been to redistribute knowledge from this infrastructure into other infrastructures and to get to know the way that different contexts know and do their work. And so I don't just ask out of desperation, I ask out of beseeching your widespread knowledge about how it is that people actually get things done, because you have done a lot of work in that task. All right, so the key for me is mentorship. I run some mentor-driven classes, practicums myself in my own DH pedagogy. And this knowing and not knowing in together is actually a quote from one of my students, where they were on their way to graduating with their PhD, and they took my DH seminar and practicum relatively late in their career. And I met them in the library just the other week, and they told me, Allison, I just thank you for allowing there to be a space where I could not know something. And that was really critical to me, because while I agree that I do strive to do that, I actually, as I was listening to them explain the value of that, certainly within the PhD granting process, which is it's a real doozy about training people to pretend that they know everything sometimes. That the space to know and not know in a context is actually an incredibly freeing one, and that she brought it to my attention was critical for my understanding of how I have come to think about mentorship. You could also think about it as coaching. Lisa Spiro talks about a very similar approach to this sort of interaction at not necessarily a one-to-one level, but at a peer-to-peer level. I think that's also a major distinction. Mentorship can be one-on-one for sure, but more important than it being just one-on-one is it being more flat, less hierarchical. It can be one-to-many. I'm in a database group. It can be one-to-many, but it should be flat rather than being hierarchical, one-down. So if coaching is a word you prefer, I agree with all the things that Lisa has to say in this short piece on DH as well. And that might be a more valid word outside in a context outside of teaching in the academy. So another thing that mentorship does is it points out what computing brings that's actually new to the context at hand. So we're teaching a task-driven context-based class or mentorship opportunity. And what mentors actually do is reframe. So as information comes in and the learner is trying to figure out how to assimilate all of this knowledge in the context of production, that meaning making that they're in, mentors can actually do their best job showing what's actually new and what's just a reframing. A lot of metaphors happen here. Oh, well, loops are just like blah in your context. Or, oh, well, if you're trying to break this big problem down into smaller problems, think about it like this. And it can really help in that way. It's really critical in doing that work of bringing something that might seem abstract more down to earth. Mentorship facilitates conversations about the types of approaches suited to the tasks at hand. I have some experience with this when I have a lot of humanists who come in and say, I want to make a map. They come in and they say, I want to make a digital map. There's a lot of steps on the way to making a digital map, and one of my jobs as a mentor is help them to break down that task into a lot of the multiple different types of ways. For example, you can represent latitude and longitude. Woo! You know, figuring out the tools and the data types that you need to have is a question, it's a conversation about what it is you want to do. I use maps in particular because I'm going to put it at now 50% of the time when students come in and ask me to help them make a map, they don't want a map, they want a network. And so I end up having a long conversation. It's a reference interview. I should have just said that to begin. It's a reference interview. So, mentorship, and this is key. So in that same example, it teaches known pitfalls. Depending on the student, I'll say, are you sure you don't want a map? Are you sure you're not making an abstract network representation of different concepts with edges? And they'll say, well, that one. And I'm like, well, let's talk about them both, and then I can talk about them together. But showing people what the pitfalls are is even more important than showing them the actual connections, if you ask me. All right, bang, mentor-led course goal. So, to me, the absolute essential here is that learners leave feeling comfortable to play around on their own. To actually introduce people, this I draw here, of course, on Stephen Ramsey's old heuristics of playing around. Leaving comfortable to play on their own is how the empowerment begins. I have this in a few slides. I feel that the road to mastery and comfort can be playful. It doesn't have to be scolding. It doesn't have to be a hazing. Play also engenders self-discovery. If we're there to make meaning, sometimes the computer helps us, and sometimes we just do it ourselves. Sometimes the computer's just there along for the ride. And this work is the actual work of empowerment. Not only do you have a human being listening to you, but you're actually gaining techniques and skills in a context that you understand to get something done that you need to get done. Nothing better. Here's the other role of play, and I've been sort of gesturing towards this my whole, I guess, 25 minutes I've been talking. I should stop talking. I'm going to make it. When you assume computers are programmed by magic, it's harder to imagine what's easier and what's hard. The more I sort of engage with early learning in computing and in programming, when you think the computers just happen, ding, and you don't actually know the steps that it takes to, say, make Facebook, I'm going to use something big, right? Then it might as well be just it might as well be easy. It happened, right? It exists. So it might be easy, it might be hard, I don't know. That is the opposite of what I would like to engender in the classes that I'm pitching to you guys today. And I think play plays an essential role in actually understanding what is easy and what is hard about computing. I bet 90% of the people in the room here have had the experience of being like, oh, that'll be simple, and then you sit down and you're like, nope. Even with practice, figuring out what's easy and hard. But I also bet that then 90% of those people who've had practice give themselves a break, right? I was wrong. This isn't easy. It's actually going to be really hard. This has happened to me before, and I can do it. That's the attitude that I want this pedagogy to convey at the small scale, and what most programmers have at the more complex sort of systemic scale. All right, so why libraries? When you're being graded, this is super hard. This is just super hard to engender. It absolutely is. There's lots about the academic class structure that make what I'm asking really difficult. I'm not saying that we aren't trying to do it at Pitt. We absolutely are. But when grades are online, that's a separate thing. I'm working with Kate Jorgensen, the Frick Fine Arts Librarian, in my building at Pitt, producing spaces for graduate students in which we try to get basically as far away from grading as we possibly can, and have been finding some great connecting success with our students, helping them with the sort of metacognitive activities in the same way of being an academic. In the same way, I'm hoping that taking some of this training out, offering a space to play outside of the context of grades, which are decidedly not play, is another part of the culture criticalness of mentoring programming. All right. So here's the part where I say I don't only and always just mean one-on-one reference interviews. I think each context-specific mentorship group can be similarly structured, and we offer some of this in the paper. So if you want more academic speak about these steps, you can read David in my paper. So we argue that the learning goals for these mentorship-led structures can be as abstract on our part as algorithmic thinking. The work of the mentor will be to connect this abstract concept to the local concept of let's see, let's pick something else. Well, I mean, the examples here are going to be humanists, so I'll stick with humanists. But it could be people trying to do mapping. It could be people trying to balance their budget. It could be people trying to make a video game, right? Text or not. So algorithmic thinking. In the humanist context, we talk about this as the ability to distinguish what a human does better than the computer from what the computer does better than the human. And this involves being able to understand what thinking like a computer could actually mean. And small-scale practice on this topic would do great. Given where you are, how do you get to where you want to be is an easy question when you're asking someone to get from here to across the street. We have the heuristic understanding of how to move our body through space. The mentor's job would be to help a student start to break down in the context of something they actually want to get done, which might be the Fibonacci sequence, frankly, if you're talking to a biologist, right? How it is that you'd actually get a computer to do what you want to do. So for example, humans read and computers loop. Humans, I stand here as I guess a rogue digital humanist. No, a lot of us think this. Computers don't read. They can analyze statistical likelihoods across tokens. Humans read. Computers loop. Humans have big goals and small subtasks, but we tend to think at the level of the course of direction, like Licklider said back in the day. Computers have small subtasks. And thinking about the distinction and figuring out when one thing is best in the context and the other is part of this mentorship arrangement. Goal 2, looking stuff up. I mentioned Stack Overflow before. When do you know that you have to look something up? I'm gonna get old school on here, right? Back in the days, back in the 80s, you had a manual and you had the computer. It was the Wild West. And if you didn't know what to do, there wasn't an internet to go to. One of the things the internet has done is sort of, I feel, made everybody think they're supposed to know everything all the time, no matter what. And it's actually the opposite, right? It's actually a bona fide, I'm sitting here talking to librarians about this. It's a bona fide skill looking stuff up, right? You guys know how to help people look stuff up. This is in your wheelhouse. It's absolutely key to this approach. When do you actually, when is it that you just didn't understand, and when is it that you just don't know the facts yet? 3 is iteration. No matter how much experience we have, especially in computing, we rarely, if ever, get it right the first time. You hit run, you hit compile, you run the thing, and it says absolutely not, and you can't take it personally. It's like drafting and writing, to give a metaphor, but somehow it feels experientially harder in my experience. When students are like, I'm gonna get the computer to do my bidding, right? And they get themselves in the position and they do every step right and they follow it and then they hit run or they hit, play or they hit whatever and the computer just, well, it can do anything, right? It can do anything from absolute blank stare to actually proactively telling you something rude, right? And it feels somehow worse, but it's not. You won't get it right the first time. The best programmers just keep pushing on. They know it's not personal. They know it's not up to them. They know it's a semicolon. They know it's a slash. They know it's the things that it always is. And you just figure it out and you move ahead. I say this knowing that plenty of people get very frustrated, but Life is frustrating sometimes. All right, this is 4. This isn't in the paper, but it's the one that I learned from doing that work on the Intro to CS class. A lot of the work of producing these mentorships is just producing context-specific examples. So this is actually a quote from a different student of mine from back in the day. I mentioned it before. She was learning about data modeling, producing a relational database, and when you go, I guess this part is in the paper, when you go online to lynda.com or whatever it's called now, and you try to learn about how to make a FileMaker database or relational, it's, you know, they use invoicing and pizza ordering as their basic examples. That's cool. Lots of people need invoicing and pizza topping examples. If you're running a mentorship group on invoicing, you have a lot of LinkedIn Learning. A lot of LinkedIn Learning videos now to show. But my student had to say this. They're talking about pizza toppings, and I'm trying to think about German conceptual art. How do I make that leap? That's the goal of mentorship. I believe that there's the ability also, she brought that problem to me, but the structure of the problem sets that you offer in these, problem sets are a perfectly traditional and fine way to do it, is that we structured them slightly differently than the traditional CS problem set. Especially for humanists, that last one there. So providing an overview of why we're asking these questions in this way, background to the problem, separating out planning the approach from implementing the approach is part of the algorithmic thinking versus the programming section, and then actually taking the time to do interpretation and making sense of our results. I'm not going to ding CS too much for this, but they just don't emphasize that because it's not as much of their tradition as it is for humanists, and it's really critical in the context of these smaller spaces to figure out room for making sense. So for example, the problems that I produced, which is fine, used prisoner's dilemma, but it used prisoner's dilemma in the context of how social scientists use prisoner's dilemma to actually model human behavior. So thinking that the people in this subsection would actually need the model to work and then would program it is how I sort of went ahead with that. So, can we give it a go? No problem? Thank you for your time, and I would love to have more conversation with you for our last time here. Yep, no, I was hoping so.
Fantastic. So we are running a little bit ahead of schedule, so we have plenty of time for questions before we do our morning break. So, any questions?
Oh. Are you going to do it? All right.
No, you can.
It's up to you. It's up to you.
Good morning, David Palmquist with Cal State Fullerton.
Okay.
I was just curious if you are familiar with the carpentries.org and whether you use that at your institution and leveraged their open source curriculum.
Which .org? Carpentries. I actually am not familiar with carpentries.org, but if it offers a play space for producing these sorts of contextual problem sets and models, I think that sounds amazing and is exactly the sort of structure I mean, yeah.
Yes, it's a nonprofit that's dedicated to giving computing skills to social science researchers, and they have many problem domain specific curriculums as well as more general ones. That's
great. That's great for the social science context, yeah. I would still be aware that the social science context is a context, so we would need to work, and I don't mean that in a bad way, I just mean it's been my experience taking anything designed for one context and recontextualizing it in another is a lot like building it again. Other questions? I see there's a mic.
Mary, front here? Oh. That was pretty much my question. Okay.
For that one, we could, frankly, if people know of different sites for different domains that can help structure these mentoring groups, and I can say them out loud onto YouTube, I'd be happy to just pass them along as sharing mechanisms.
I'm reflecting on how you started with the example of teaching language.
Yeah.
And of course, the human ear is very forgiving in errors in grammar and vocabulary, and the computer is not. At the risk of pushing the human mentorship out in favor of trying to do this at a scale, have you seen computer languages or programming tools that can act as a mentor, be not quite so literal in understanding language and grammar, and help in the suggestion of, I see you were trying to do this. Did you mean to structure your computer language or your computer code in this way?
Yeah, so, I mean, the short answer is no, I don't think I have a direct answer to your question, but the longer yes answer to your question is that I won't ever push out a human person, but I would actually say that for better or for worse, reframing, making syntax errors as part of play is what I really want to emphasize here, because computers aren't telling you you're wrong. They're saying, I don't understand. I don't get it, right? And like reframing this, like for example, just parsers that color code your code as you go on is part of this process, right? It can actually just sort of say, ding, 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 I'm not going to get this, I'm not going to get this, or the new like Swift, right? The new coding sort of environments where you do it and it runs it at the same time, so you can sort of see as it goes. So I hear what you're saying, and I don't disagree with you, but I think what I'm arguing more here is reframing the syntax error as help me.
Yeah. Okay.
There's someone in the front. Is that possible? Is it possible to reframe the computer as just a 5-year-old that constantly needs help? Thanks. It totally is one, right?
Yeah, I actually work with Lisa Spiro, who does a fair amount of this, actually. And one thing, maybe it's less of a question and more of a comment, is that when we're teaching these things, we find it difficult to not just do the work for the student. So that's one thing that needs to be part of this conversation as well, reframing, not just doing.
Yeah. Yes. Yes, this is a different talk. What it is to do this for 35-year-old people will be different from what it is to do for 20-year-old people, I believe. As we grow up, we take on our own obligations and needs to actually produce our own environment in different ways. The college years, the young adult years, are very particular years in becoming yourself and who it is that you want to be. And so sometimes the sort of closer mentorship one-on-one opportunities that arise are full-blown mentorship opportunities. Trying to figure out what a 20-year-old person actually wants gets a lot closer to like what they want from their life, also to what they want from the task. I'm not saying that that actually gets better as you get older, but as you become more assured in your tasks and your goals and more situated in what it is that you want to do, coming from mentorship, that relationship, it becomes more actual peer mentorship. So I absolutely hear what you're saying, working with a lot of people who just need to get it done. I think that's a real, in fact, I'm taking that in sort of more deeply. When I talk about task-driven and goal-oriented, I don't mean getting to the answer. I mean getting to the functional utility of what it is that you want to do. So sometimes that will have an answer. Does my budget balance or doesn't? But certainly in the humanities, the humanities are about questions that we ask generation upon generation. They don't get answered. And so that's the clarification that I thank you for allowing me to make. I don't mean goal-driven. I don't mean answer-driven. I mean getting done what the person needs to get done. I'm ready.
Hey, over here.
I see you.
One of my favorite things when I started coding was if there was an error, it really was my fault. And that was one of the things that attracted me most to software. I'm wondering, do you think there's a gendered aspect of that? And how do we serve both the people that kind of want to view it as like, oh, it just doesn't help me, and that kind of interaction with the computer versus another one that's really just like, no, this is a rigid system that if I apply myself to, I can make it do what I want.
Right. Wow. Without veering too far into psychology, I would say that it's one thing to say that it's your fault that a computer program didn't work, and it's another thing to say there's a reason for it. There's always a reason why something doesn't work in computing. There's always, not only is there always a reason, you can almost always find it. And I think that's very attractive. So I actually don't, I don't, I don't want to put off onto the computer any more agency than it already has assumed in this world, but I would say that I think that balance is easy to strike when, especially when the computer doesn't do what it is that you think it's going to do. Mentoring people into the fact that it always will be fixable, or at least that always has a reason, is sort of the same thing as what I'm saying. I would say that I see them as very compatible. I don't think either way it's your fault for trying and playing. I think fault in general I would remove from play if I could, but reasoning and making mistakes and misunderstanding are all parts of play, to me. Are there other questions? Right on time, right?
All right.
Thank you.
Thank you so much for that wonderful, wonderful closing keynote as I try to master Hello World. So we're a little bit ahead of time, but we're good. If you're doing a lightning talk or a scheduled talk and you have slides, please bring them up during the break so we can hit the ground running at 10:15. So lightning talks, scheduled talks, bring your presentations up. And with that, we are at our morning break. 10:15.
Thank you.
And welcome back from break. For the folks who are giving lightning talks, you all came up and gave your presentations, the slides to your presentations, excuse me. If you could line up over here to my left, next to the stage, we can go ahead and get you guys ready to go. Before we do our lightning talks, though, we have a few words from Joy Banks from Clear. Clear is our fiscal sponsor, so let's put our hands together for Joy Banks.
Hi, everybody. I'm Joy Banks. I am a program officer at Clear, and I hope that you all have enjoyed your Code4Lib experience today. This was my first time being here, so I've enjoyed the conference. We just wanted to take a very quick moment to introduce you all to Clear's new podcast, Material Memory. I'm going to skip most of my slides because they did squeeze me in at the last minute. But this is one of the ways that we're hoping to sort of spread our audience base beyond our publications. We'll have theme-based seasons, and I was the host for season 1, which focused on indigenous languages and the work being done to digitize and preserve these. So we have episodes 1 through 4 online now. We'll be dropping episodes 5 and 6 pretty soon. I hope that you take advantage of your Wi-Fi now so that you can download an episode or 2 to listen on your way home. The slides actually will also have the trailer for season 1 in them, so you can take a look at that. Our upcoming seasons may be of interest to you as well. We're going to be doing seasons focused on born digital archiving, how the climate crisis is sort of affecting the human record. We will have a season focusing on HBCU library collections, and then in season 5, we're hoping to focus on AI and what sort of preservation of that looks like. So I encourage you to contact us if you're interested in any of these, have ideas, especially for season 5. And here's the website. It's material-memory.clir.org, which I've said quite a bit over the last few months as I've hosted. And thank you, and I hope you enjoy.
Microphone. Oh, yeah, you need it, Mike. You do. You do.
Okay, it's a hot dog. I just want to give a shout out to Clear because without them, it would be very difficult for us to have our mailing list. And if we didn't have our mailing list, a lot of this wouldn't be happening. So thank you very much.
All right, so we're going to start our lightning talks, and up first we have Wilkie speaking about Occam.
Yep, cool. I have fans. Okay, how does this actually work? Like that? There we go. All right, my name is Wilkie. I'm from up the street, University of Pittsburgh. My family's from Johnstown, so Andrew Carnegie actually does suck. I'm a systems researcher, so I work on actual software archives, the ones that actually work. So the idea here, our motivation is science for the most part, because science traditionally is using more and more software, and the problem is that we want reproducibility, but there's no preservation strategy. So software kind of, well, the problem is that software decays quite a bit and degrades without us knowing. So the main point, though, that I'm making throughout is that packaging content just straight up is not really enough. You can't just put in a zip file and say that it's going to be preserved or usable later. So software decays. So we reframe the question with how do we allow software to degrade gracefully? So I don't know. Nobody knows. You can't predict the future, which is a real problem, but we try. And we think about the technology we have, containers, virtual machines. These are great for packaging things, but they're not preservation tools at all. So we kind of, if we lean on them and they are software themselves and they also degrade, we are in a tough spot. So we again reframe the question, what do people actually want? So developers, humans in general, what do they want? Not that developers aren't human, just, subset, subclass, You want to find useful software, you want some discovery, you want to run it, you want other people to run it. Hopefully you want people to curate their own content. And everything you put in this list, you want to make sure that, oh, it remains true in the future. All these old things that you might want to still use and find. So we want to design a system around this. Traditionally, we build OSs around the idea of we build programs for the OS. And we need to start thinking about, well, how do we build an OS to run any program and have software kind of degrade and still be usable? So in our system, we did this. We packaged our software, and this is just kind of an image of what's possible. We package it up in its own little encapsulated form, just some metadata, it's normal data. And then we basically say, okay, I want to run this. So we're going to make a container, build a container on the fly or a virtual machine, put everything, all of its dependencies, track its origin and provenance along the way, put the source code, zip files if we need to unpack them in the container. And then once we run the program, we can throw away the container, right? We don't want to preserve that because that's not actually how it works. So to use an example here, let's run Doom because I'm a published author in Doom. It's really great. It's an old video game. And the thing is, your phones can't run this. That would be silly. Your phones don't run DOS, as cool as that would be. So it's too old, so you have to find an emulator. So an emulator is a piece of software that bridges some sort of gap. And then once you have an emulator, you can do kind of a recursive step on it. It's software that needs to be preserved, and then how do you run that? And you can create a bridge, basically a path from the thing you want to run to whatever hardware you currently have, and in the future, keep building layers. So you build a container for that, deploy the container, whatever it ends up being, whatever technology you're using, and then you can reframe that question at a later point. And let's say you can do that, right? So we saw, Doom's up here. It's running in the browser because there's some sort of browser emulator. You want to run a level. People are building new content for this game 20 years later. So how do you frame that? Well, you wrap the level. It's just a file. How do you open the file? You open it in this program. Then how do you run the program? And you start building these layers. That's the idea. You reframe the software preservation problem as a layering problem. How do you encapsulate the data, and how then do you run this? What do you need to run that with? What do you need to run that with? And keep building layers as you need to gracefully degrade. And you can swap Doom out with anything, graph visualizers, simulators, anything that reads or writes data, and there you go. So the great thing about building an operating system is that you abstract things out. So one of the things an operating system does opens files. So yeah, I can open a file here in this software object I have in a boring web editor. But I can also, because I have the ability to run something in DOS, and I have some ability to input a file, I can open it in Microsoft Word for DOS inline in my browser. That's it's the same idea. Why not? And since I'm not the boss of you, you can do your own thing, your own person. You can open it in WordStar. Again, do what you want. I don't care. You could do that if you want. So the idea is we're creating these abstractions. Once we have this in place, we can do this. We can make an operating system idea to preserve software, abstract it out, provide a bunch of functionality, and really build this. This is what we really should be doing. So it's a big project, does lots of things. You can go on the website here. You can contact me. Here's some laughs. Obviously, you're laughing at the please fund me part, not the no blockchain part. Blockchains, yeah, I'm a distributed systems researcher. Useless thing. Don't do that. Web-based, self-hosted. I want you to have your own thing. You're not beholden to me. Take a look at it. Email me. Please let me know what you think. And yes, if you have money, please give it to me. All right, thank you.
So up next, Francis channels his inner Giarlo.
I'm just going to make this happen because I know it's messed up already for our purposes. You get to listen to Dre making weird noises at the computer one last time, everyone. Yay. All right. And Francis, I'll just let you find your slides. Where? Oh, there you go.
I have no slides.
Oh, that makes it easy.
I have no slides. You can take that off. Or you can leave it on, it's cool. I will channel my inner Mike Giarlo for my presentation. For those of you who've been at Code4Lib for a while, I don't have a vest. I did have the neck beard, so I'm partial Giarlo. But he always did this, and it's around this community, and it starts like this. If this is your first time at Code4Lib, make your hand go up. Fantastic. If this is your second Code4Lib, make a hand go up. Ah, this is a group that I like. Thank you for coming back. If this is Code4Lib number 3 through 5, make hand go up. Thank you all for coming back. If this is Code4Lib 5 through 8, y'all are still coming back. That's good. That's good. If this is Code4Lib 8 through 10, this is Code4Lib 11. Nice. The streak's gonna be broken this year because I didn't see Karen Coombs at all. 12. 13. Oh. Ryan Wick did register for this conference, so I think we allow him to keep that streak going. He did register, but he couldn't travel because of Mexican lager virus. All right, I hope you all will think about the next Code4Lib. I think somebody's gonna talk about volunteering. This conference is about people coming back. I really like the 2 to 5 group. I want y'all to get to 5 through 10, and we may have lost the streak. You got to keep coming back, the 2 of you, because you are now the oldest. Thank you. I bought you all 2.5 minutes.
All right, thank you for that, Francis. Up next, we have Ian Wall speaking about Project Cerulean. Let me a second to find the slides. You're up here, right?
There we are.
Okay.
Hi, I'm Ian Walls. That's been said. I am the Folio implementation lead at Bywater Solutions, and I'm not here to talk about either of those things. I'm here to talk about Project Cerulean. Okay, so when I don't know if anybody else is like me, but when I first heard it, I immediately thought of that episode of the X-Files. But it is actually a Pokemon reference, and spoiler, I came up with the name, so it's fine. So what is it? It is an open source, web-based ETL interface that can handle arbitrary data schema, sort of with the idea of being able to separate the data processing work from the writing scripts work. If you're not familiar with ETL, and I wasn't when I started this process, it just stands for extract, transform, load, take data out of a collection into constituent records, do something to those records, and then put them somewhere. So conceptually pretty simple, and basically this is what a data migration looks like, at least to me, a lot of the time. So why am I doing this? Well, at Bywater Solutions, our migrations team works really, really hard. We're doing 1 or 2 migrations a week, have been for the last several years, and anything that can save their time and sanity is really important. Also, as I mentioned, I'm the Folio implementation lead. You may know Bywater Solutions from our work with Koha. Well, now we're going to do 2 systems, and wouldn't it be great if we could use the same toolkit for both of those kind of things? Right now, our migration tools are very Koha-centric, so if we can abstract that out, I figured, hey, there's a bit of a win. Also wanted to have something with a little bit more interactive data analysis. Right now, we facilitate communication with our partner libraries to do data cleanup, but a lot of it involves emails back and forth and forms being filled out and Zoom calls and all that. If we could have something that's a little bit quicker, I thought that might be useful. And also, I really just like making stuff, and I haven't gotten to do that in a couple years, so. Diagram of the original crazy idea, you can kind of see the ETL in there if you really squint. You got source data, it gets ingested, put into some sort of cloud. I imagined Elasticsearch at first. Then a bunch of workers do stuff to it. People can look at it, and at some point it's ready to get imported into whatever system you're sending it off to. I have code. There is an implementation. It's not just vaporware. It's just really early versioning. It's based on the Silverstripe framework and PHP ETL. So there's your flavor for it. I'm using Postgres under the hood with Apache, and the secret sauce to make it work well is the JSON editor.js library, which allows you to provide a JSON schema, and it will automatically render a web form that produces JSON that's compliant to that schema. So I don't have to muck around in Silverstripe's interface to make a bunch of conditional text fields and checkboxes and all that sort of stuff. The end result being that the ETL processes wind up being code, or being data, not code. They're a JSON file describing this is the process, and so long as you have all the underlying extractors, transformers, and loaders, it will just go about and do its thing. It also has a concept of a sort of a scratch space where we save records sort of temporarily, so you can do your extract without necessarily knowing how you're going to do your transform and your load. You can do an analysis on the data before those steps. Here's some extractors. The ones on the left came out of the box. The ones on the right I wrote. Here's some transformers. The ones on the left came out of the box. The ones on the right I wrote. Here's some loaders. I don't have a graphic for that. The ones on the top out of the box, there weren't very many options, so I added several more just to make my use case work. So it's up, it's on GitHub, it works. I mean, it's not super polished at this point, that's why we don't have any actual images of the GUI, but it's there, it's licensed GPL3. I'm hoping to keep adding to it over the years, and yeah, I'd be happy to hear anybody else's use cases and needs to be able to make it something that is actually helpful to other people. So at SecJol, Twitter, Slack, Pokemon Go if you want to be my friend. I was throwing Avatar at the beginning. And Ian at Bywater Solutions. Thanks.
Up next, we have Andrew G. speaking on OpenONI.
All right, hey everyone. I'm Andrew Gerhardt. I'm from Pennsylvania State University, and we are, one of the projects that we're working on is a project called the Pennsylvania Newspaper Archive. And one of the reasons why I'm talking about it today is because actually officially today we are in partnership with University of Nebraska at Lincoln and University of Oregon releasing OpenONI 1.0. The code structure of the application, it's a Django application, so Python on the back end leverages Solr for being able to do index and searching, MariaDB for storage of data about the collection, and the RACE Rodent Advanced Image Server, which is supported by University of Oregon. OpenONI 1.0, it's the components there. Python is now 3.6. Django is 2.2, MariaDB is 10.4, and Solr is now 8.3. The reason why that's really important is because the project is now supported long-term. We have a lot of institutional collaboration. It's based on foundational work by the Library of Congress, creating the Chronicling America project. When they decided to discontinue work on that project, then these institutions picked up the mantle. The infrastructure for the project, it leverages Docker for local development and for production deployment. Because of Docker and the local deployment of Docker, then you can bring in a new developer up on the system in about 10 minutes. Server can operate in approximately 2 gigabytes of RAM, and your newspaper titles and issues are organized by NDNP bags currently. It uses the Library of Congress Bagot standard, and we refer to the groupings as batches. Batch loading is triggered by our digitization department, so I'm going to talk a little bit about our how we're leveraging ONI here. Batch loading is triggered by our digitization department, so not our systems department, and the batch loading process is governed by a little script that we wrote called Panabot. So we have a few different points of interaction. We have the actual website, which we'll get to in just a minute, has full IIIF support. The structured Bagot files are all available through the system. And then we have all the files stored within Isilon file share, and everything's available over NFS. And then we have the chat interface, which allows for our non-systems people to be able to see what's going on with the system. So overall, this is the kind of the way that we flow everything through. Somebody creates the original, potentially is microfilmed, and or from the original goes to the TIFF, and then digitization collects all the images, goes through the vendor, et cetera, et cetera, et cetera. You can see there's lots of different steps, but I'm running out of time. So down here at the bottom, one of the things that's kind of fun about this is that digitization, again, they identify the batch to load, and then the Panabot actually goes through, performs the loading, and then notifies the PCD group of the status. So in Slack, within our library, that's kind of what it looks like for them. They can see that it's all getting copied over and that things are going successfully. So some vital stats about the system: 210 titles across 219 years, about 1.1 million pages indexed and searchable through OCR text, about 12 terabytes of newspaper images. So it's a pretty big system at this point. And we're currently working on more titles coming in from the state library and a number of different historical societies throughout the state. So I have 1 minute left. So this is what it looks like. You can browse by title, go through, sort by different counties, and as you're looking at one of them in particular, has a nice slippy interface using OpenSeaDragon, so you can actually go through and pan and zoom across the whole interface. There's also the ability to browse by date, and so on and so forth. If you have any questions, I'm on Slack for Code4Lib, Andrew Gearhart. You can also email andrew@psu.edu. I'm also Andrew Gearhart on Twitter, so any way you want to get in touch with me. So I've got 15 seconds left. And
All right, thank you, Andrew. Up next, we have Eric Beck speaking on using inferential statistics to evaluate the FDLP. Let's see if I find you here. You have slides, right?
Mm-hmm. All right. I don't know the name. You just go through them. Not that one. Not that one. Hi, my name's Eric Beck. I'm from Sac State, CSU Sacramento. Yeah, and I'm going to talk to you today about this little project I did in R to evaluate FDLP depositories, basically service delivery and FDLP depositories. It might just be on the desktop now. Yeah. Try the PowerPoint right there.
Oh, sorry.
Yeah, that's it, right there. So you guys probably know what the FDLP is. It is, there's, depositories in most of your libraries. It is the part of your library that no one goes to. And also so it's the program by which the federal government deposits its publications in depositories across the nation so that the average citizen can go to their local library and find out what old granddad government's doing. So it's kind of an old, outmoded model for information delivery, frankly. And because of that, there's been this ongoing trend of institutional disinvestment. So I wanted to measure that amount of divestment that's going on in the program. And to do that, I looked at this self-survey that FDLP depositories do every 2 years, where they report on things like their staffing level and different services that they're providing. So, looking at different responses to this survey, I had this problem of several factors all contributing to this one conclusion, and I needed a way to weight the different factors to find out which ones were more important. So I used this method called principal component analysis, which basically finds out which of your nodes in a data set are most discrepant, and it gives you a method of weighting. So using those PCA vectors, I created a score for every single depository across the country, and I associated those scores with longitude, latitude coordinates, and then made this nice little ghost map in R. And then I also took the mean of all of the scores in a particular state and created this more useful map of just average amount of investment in the different regions. I then put this map on a poster and took this to the FDLP conference, where I then stood around with a bunch of depository coordinators, and we all laughed at how badly Vermont and New Mexico are doing. Unfortunately, I'm very good friends with the regional coordinator in New Mexico, and she said, well, that's not right. We're doing better than that. There's something wrong with your scoring system. We probably have depositories out in the desert that we don't know about, and they're outliers or drawing our score down. And so I'm saying, okay, so you're saying that there isn't a phenomenon of geographical clustering here. Well, that sounds like a null hypothesis. Let's test it. So I ran this test. So geographers have this method of finding clustering in geographical space. It's called autospatial correlation. It's supposed to measure whether or not there is a causal relationship between a phenomenon on its neighbors in space. It is kind of like dicey statistics. There are a lot of statisticians who don't think this is a reputable form of, you can make reputable conclusions from this. But nonetheless, I ran Moran's eye test through the old R machine, and it did find that there is an occurrence of clustering quite a bit, although not a statistically significant amount. I just missed my confidence interval by 0.75 of a percentage point, which means that I can't publish this, but I can bother you all on a Wednesday morning in Pittsburgh. So thank you for listening to my TED Talk.
Let's see if we can find these slides a little quicker this time. No. Is it here? Yeah. Next up, we have Laura Alana speaking Beyond the Repository.
Thank you. Good morning, everyone. I'm Laura Alana. I'm the Digital Preservation Librarian at Northwestern University, and I'm going to spend the next 4 minutes and 50 seconds telling you a little bit about a grant project that I have been managing for the past year and a couple months. Beyond the Repository is a 2-year IMLS National Digital Platform grant. It's based on a 2017 planning grant of the same name. In the planning grant, we conducted research into obstacles to interoperability in different digital preservation tools, specifically looking at integrating local repositories with distributed digital preservation services. We discovered that digital preservation is hard. I know, it's shocking, right? And that the main obstacles to interoperability are both technical and curatorial. Our research showed that most people had problems transferring content from their local repository to a distributed system. They often accomplish this when it was possible, because a surprising number of people we talked to were members of DDPs like AP Trust or back then Digital Preservation Network, but hadn't actually sent any content to them. But those who were actually successful in doing this were often doing it with different tools that they kind of ad hoc shoved together to try and get their whole system to work. And then on the other side, people were struggling with making selection decisions in terms of sending only a subset of their content to distributed services. So the current grant that I'm working on, it brings together 2 different teams of people, including digital preservation practitioners like myself, as well as representatives from different repository and distributed digital preservation service organizations. And we are trying to accomplish the goals that you see here, namely to create a shared Bagot profile to increase interoperability between local repositories and distributed digital preservations. And part of that is also implementation of this new profile. So local repositories, Fedora and DSpace, are implementing it, as well as distributed service providers, LOCKSS and AP Trust. On the other side of it, a different team of people is working on a curation toolkit designed to help people make the selection decisions that they need to when choosing a subset of their materials for distributed digital preservation. I'm going to focus mostly today in my next 2 minutes on the Bagot side of things because I think it might be more interest to this audience. You can see a general overview here. We are finished with the first year. Bagot profile is done. Cross that off my goals list for 2019. And right now we are in the development phase. So folks at Fedora, DSpace, LOCKSS, and AP Trust are working on implementing this in their tools and systems. So what is the new Beyond the Repository Bagot profile? Throughout the grant, we have been guided by 2 main motivations. One is obviously promoting interoperability. It's the whole point of the grant. But also, we don't want to inadvertently create other barriers or challenges in digital preservation. So to thread this needle, we've kept to the existing Bagot file packaging format, which is the canonical BAG spec, and the Bagot profile spec as much as possible. So the Beyond the Repository BAG format introduces 4 new metadata fields. Previously, a BAG only defined checksum types for the payload and the metadata files. These were tags manifest required and tag manifest required. But in Beyond the Repository, we also include manifests allowed and tag manifests allowed, with the idea that a local repository and a distributed service might use different algorithms, and therefore a BAG might get rejected as invalid. We also introduced the BAG producing organization tag, which of course in a distributed system might be different than source organization, where the BAG was originally created. And finally, we also created the tag data export info, which captures any information used to restore the data eventually. Next steps, like I said, these different organizations are implementing the Bagot profile, and then hopefully we will become interoperable with all of our tools and systems. Thank you.
Hey everyone, you might know me from, being your MC, for running around with a microphone, and maybe doing something with giveaways this year. Did I mention my name, Mary Jean Gillespie? Okay, anyway, I'm not important. What's more important is Code4Lib and all of you. And I'm here today to talk about Code4Lib and you. And I know Code4Lib 2020 isn't over yet, but I am always looking to the future. And I am hoping that Code4Lib 2021 might be an opportunity for folks to consider, volunteering. What is really nice with Code4Lib is because we are community and people-based, there's always processes and opportunities for folks to get involved. So I am currently on the Code4Lib wiki page, which is wiki.code4lib.org. Some folks didn't know about it, so that's why I'm hyping it up. And every year, some pages are really outdated. Please, you can judge all you want, and if you feel like it, you can totally update pages yourself after getting a wiki username. But I want to draw your attention to the this Code4Lib 2020 conference in the upper right-hand corner, or mostly upper right-hand corner. And we have Code4Lib 2020. When we get to the point of establishing the Code4Lib 2021 conference, we are going to be updating this section, and we're going to have a section for conference committees. And so the reason why I'm so excited about it is because you can actually do a lot of this volunteer work remotely. It's great. Usually it's a minimum or a minimal requirement of work. I know we're Code4Lib, but really the website committee and streaming is the most technical that we have in terms of requirements. Everything else is meetings or emails. Like, for example, I chaired the sponsorship committee this year. Thank you to my sponsorship committee, Andrea, Scott, and Jana. Really appreciate y'all. And we sent out emails. That was it. That was the committee. And then we would check in 30 minutes or less every week or so to see where we were at, right? So right now, we don't have signups for the 2021 Code4Lib conference. We'll determine the location soon after this. But we will be sending out emails and also posting on our conference website to encourage folks to sign up to volunteer. So it's a rewarding experience. If you're part of an organization that has like service requirements, this counts. Or we'll do whatever we need to make it work for you to qualify. But yeah, so thank you so much for your consideration. I know not everyone is able to come to Code4Lib every year, and we've been very lucky with our community, both here in the room and those at the live stream, that we have their support, and we cannot thank you enough for that. So if you have questions, I'm always available on the Slack and on the Twitters at mjingle, like jingle bells. Yes, it's a thing. And yeah, thank you so much for your time.
All right, thank you for that, Mary. So next up, we have Michelle Soronovsky speaking about Google Sheet add-ons.
Hi, my name is Michelle Soronovsky. I'm a developer for the library at Lehigh University. And last year, I partnered with Lehigh's metadata librarian to build a Google Sheets add-on that helps to automate the process of finding the best OCLC record for an ISSN or an ISBN. It was for a project that the librarian was working on, a specific project. Creating a Google Sheets add-on ended up being a good platform for this tool because projects like this often have workflows that involve Google Sheets to start with, and then we could also use this spreadsheet itself to set up the match criteria. The add-on uses OCLC's API to look up either the ISBN or LCCN in each row in the spreadsheet, and then it uses the match criteria also in the spreadsheet to select the best record. It will insert data you specify into the spreadsheet from the MARC records. The add-on also has the ability to then email you all of those records in one file, excluding duplicates. And one of the most recent features we've added is the ability to add fields to be included in the records being emailed to you. So, for example, you can set up a 900 field to be added to each record, and when you receive the file, the fields will have been added. I'm planning to add support for ISSN numbers and matching and writing values from the leader to the spreadsheet. Anyone can install this Sheets add-on from the add-ons menu in Google. If you just search for MARC, you'll see it. It's called MatchMark. And you can also find the source code in GitHub. I not only wanted to bring our project to the attention of Code4Lib but I also wanted to just highlight the Google Apps Script platform itself. You can use it to create add-ons for several Google apps. So far, I've only worked on a Sheets add-on. But on the plus side, the platform has the ability to connect with APIs and databases. You can have it create files within Google Drive. It also sends emails. It has a feature you can use to automatically run scripts at specific times. Lehigh is going to be migrating to Folio, and I can see using Sheets add-ons for building things like reports, and also maybe even custom workflows pushing data into Folio. Also on the plus side, there's not much setup involved in creating add-ons. You can write the code directly in the browser using their editor, and the syntax is client-side vanilla JavaScript, so there are lots of resources online, and Google itself provides tutorials and documentation. On the downside, the code you write actually lives and runs on Google servers, so if the APIs or databases you want to connect to are behind a campus firewall, you need to work around that. And also there's a limit on the running time of a script, but I recently found a blog post with a suggested workaround for that issue. The other plus side is you can share your scripts in the same way that you share a Google Doc, or you can publish it for anyone to download. If you're interested in hearing more about the project or the platform, I'm going to be talking about it during an OCLC Dev Connect webinar on April 1st. And a quick shameless plug, my team is looking for a senior developer. We're a small, close-knit team, and we're able to collaborate with the library staff on projects like this. We have the freedom to explore tools like this to solve problems. If you have any questions about the project or the platform or the position, I'm happy to answer any questions. Thank you.
All right, we're going to get right to the scheduled talks. We just need a minute to get everything set up, so bear with us.
Grumble, grumble, Dre is grumbling, grumble, grumble, grumble. Incoherent muttering. There's a thing with a what's it that has to do the what's it, so on and so forth. Keep changes. Who's our first talk? All right, let's see if we can find that one. So one of these? No, those were both lightning talks. Okay, bop, bop, bop. I wish people would close their slides when they were done. Grumble, grumble, grumble. We did this one. We did this one. Did we do that one? I don't know. I don't know anymore. New approach to old. Okay. Oh, you know what? We don't need. Grumble, 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 grumble. All right. Keep changes. Yoink. 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 Okay.
Watch this. All right, thank you, Dre. Our first talk is a new approach to old metadata. I present to you Huma Safar.
Hello, everyone. My name is Homa. Thanks for coming to this presentation. I hope you're here either because you're fascinated by or frustrated by MARC data, since that's what we're going to be talking about. MARC is a very legacy format that is still quite prevalent in a lot of catalogs, even though it was... Thank you. Right, even though it was developed decades ago for a purpose that has almost no relevance to what we do today. It's famously challenging to work with, and it can be discouragingly difficult to do anything interesting or complicated with it. So I wanted to talk about an approach that I worked on last year to try and better understand what MARC is about. And I should say, I'm approaching this from the perspective of engineering and not so much cataloging. I
have immense respect for the way catalogers can understand and explain MARC data, but like from the point of view of kind of building systems on top of it and trying to process it, there's a slightly different set of challenges in some ways. So we want to see if we can kind of approach it in a different way and use that as a starting point for building more useful and more effective ways of working with it. So I've been working in library tech for the last almost 4 years. Been in tech generally for a lot longer than that. I recently switched to digital humanities, so I'm excited to see what kinds of metadata challenges that will entail. But like I said, today I want to talk about MARC, and I want to do so by exploring this idea of MARC as language. So there's some precedent to this idea, which is expressed in this Code4Lib article that was written almost a decade ago. And in this article, the author advocates for shifting away from thinking of MARC as structured data to thinking of it as something closer to a markup language. And this is despite the fact that the standard encourages a very kind of data-centric approach to MARC in terms of tags that are neatly divided into subtags that are all labeled according to like the kinds of data that they contain. But the real story, which I think we all know, is that there's actually a lot of complexity tangled up in this. Some of that comes from MARC itself, some of it comes from things outside of MARC, like ISBD punctuation, like different descriptive standards, like local data. So this very simplistic structure does not accurately reflect what's actually going on inside the record. So the author finds that when he reframes this problem in terms of markup, as opposed to thinking of it as just like a kind of parsing problem, this opens up new possibilities for the kinds of techniques you might think to apply to the problem, which in turn leads to a more effective, nicer solution. So that's pretty neat. It's quite an interesting result, and the question is now, can we elaborate on this idea? So can we encompass sort of all of MARC in some kind of language-oriented approach? And can we push this beyond just markup towards more complex kinds of formal languages? So the fun and exciting question we're going to explore is what happens if we try to think of MARC as something like a programming language and try to use like some of the ideas that we have there to shed some light on the complexity of MARC. So I'm not going to get into any of like the deep details here, but I will have my contact info up at the end of the presentation, and if anyone is interested in knowing more about this, I'm very happy to talk about that. You can send me an email or find me on Slack, and I'd be happy to talk about how some of this like works and what this means. But the main idea of what we're trying to achieve here is we want to say, okay, what are the things that are tricky, that are annoying, that are poorly defined with MARC, and see if we can, again, like reframe, recontextualize that into something that we know kind of exists in the world of languages, that we understand to a degree, that there's some theory behind, that there's some knowledge about how to implement, and then instead of kind of like, you know, approaching MARC from scratch, kind of steal those ideas and see if we can bring them back to bear on the problem of MARC. So what does designing a solution with this approach kind of entail? So this is this sort of a summary of the framework that we start with when we want to consider MARC as sort of a language that we're working with. So we start with a kind of very simple syntactic parse of the data, and this is going to involve like the tags, the subtags, any simple structural features of the record, like 880 links or things like that. And this gives us sort of a very bare bones representation of what we're working with, right? And then what we want to do is take that and kind of iterate over it and add more and more information to it. You can think of it as sort of like taking multiple passes over this data and like incrementing what we're working with so that we end up with something that has enough information that we can then start doing interesting things with it. So we want the structure of our representation to actually be useful and informative. So if we look at the thing on the left, that's kind of what you start with if you kind of parse out the subtags in a MARC field. And you can see it's this very flat structure. It doesn't really elucidate what's going on with the data here because there's no like, you know, there's no sense of how these like bits of data kind of relate to each other. So going from the thing on the left to the thing on the right, computationally is not that difficult to do. It's a straightforward kind of data structure manipulation, but you see it vastly improves the quality of information that we have now. And if you were to think of like kind of writing a function to do something with 260s, I think you would much prefer to have the thing on the right as input rather than thing on the left, which requires a lot of extra work to do before you get to a point where you can actually operate over the data that's in that field. So this is an example of kind of recognizing patterns in the subfields of a field and making those patterns explicit in the structure, but those patterns might exist outside of just the subfields. So there might be meanings we want to pull out from like the punctuation in the data. So here's an example. I purposely chose a relatively simple 505 for this, but here we want to ignore the $A entirely and just pay attention to the punctuation and restructure what we're working with in terms of that. And again, you see, again, it's not difficult to go from that 505 text to the data structure on the right, but you see what a vast improvement it makes. So besides using structure to organize our data, we can also organize data using types. So we want to add more useful information about what type of data do we have in our record that can help us work with it more effectively. So we can start with the tags that Mark is sort of built on, but the problem there is that they're not always very precise, and you frequently have to do kind of extra inference on top of just what the tag is to precisely understand what actually you're dealing with. So we ask ourselves some questions in terms of what do we need to implement to have better sort of inference as to what data we're working with, and also things like what do we want to kind of assign type information to. So tags exist at the field level, but we may want to break fields up into different bits of data and be able to work with them separately and understand them separately. And this process can also depend on some kind of context-based computation where you have to look at things in other parts of the record to determine what exactly you're working with. So we kind of do all this work, we organize it into this one layer that does sort of type inference, if you want to call it that, on the data that we're working with. And again, we do the same thing where we go augment our representation with now some better type information, more precise and more coherent than what Mark gives us. So let's say we start with this Mark data on the left. That first phase might give us the tree on the right. And then we take that and apply those kind of type synthesis rules and come up with some annotations that help us make better sense of what we're looking at. So the point is, if I were to want to be writing some scripts to do something with my Mark data, starting with this thing that we end up with and building on top of that is a much nicer and hopefully more appealing situation than starting with this. So this is just a note that I think I'll skip over, but the point here is you can draw some interesting things out of the theory, and again, if you recontextualize it, reframe it, and you can draw kind of interesting insights that help you work with some of the weird aspects of Mark in a nice way. There's a blog post that I wrote last year that you can read if you want more details. Okay, so like I said, this is a project we worked on last year. We built a Mark processing library based on some of these ideas. The implementation had to encompass a lot of complexity just by the nature of what we're trying to do here. But it was pretty well organized, very readable, very maintainable, which are important things. It was, kind of much easier to understand what was going on than in the sort of thing that it replaced. And that comes from that framework that we saw a few slides ago. It comes from using that as our kind of guiding design in terms of thinking about breaking the problem down into different pieces, thinking about how are we going to implement these separate pieces, and then how are we going to organize them back together into a solution that is kind of maximally effective for what we're trying to do. This also gave us more powerful capabilities for doing some kinds of things that we couldn't do with sort of the rules-based approach we had before. and some things that we could do, but only with a lot of difficulty and like in a kind of error-prone way. And I didn't talk about configuration at all in this talk, but that's also a really important consideration with something like this. You have to be able to handle kind of local variations and local data, and again, that framework gave us a much more natural and nicer way to insert extensions to this processing in a way that was sensible and not overwhelmingly complicated. So this is not the end of the story by any means. What we were trying to do here is like come up with like a good foundation for continuing to do more interesting and complicated things with Mark in maybe a more optimistic way. There is obviously a limitation to Mark. Mark is not the thing that we want to build a lot of like the stuff we do these days on top of. But that legacy data still exists. We still have to be able to work with it somewhat intelligently. There's lots more things you could do with this. I had some designs of trying to tackle the holdings standard last year, but I kind of ran out of time. But it might be fun to experiment with the same kinds of ideas applied there and see if it does or doesn't help clarify any of the abundant challenges with holdings data. ISBD is kind of a whole problem on its own. We won't get into that. But another thing that might be interesting is using this and supplementing it with kind of like statistical methods or like strategic use of machine learning or things like that to fill in the gaps and kind of get beyond the limitations that are inherent in this kind of approach. Okay. I'm way under time, but like I said, here's my email. You can find me on Slack if you want to talk about any of this stuff more. I'd love to, and the slides are available online. So thanks for listening.
We might have some questions. Okay. All right, thank you. Up next, we have Sean Averkamp and Julie Hardesty. AI is such a tool. keeping your machine learning outputs in check.
Oh, right, because it's the thing. It's not the other thing. Close this. And wait. You need presenter notes?
Yes.
Okay. Oop, sorry. Don't want to spoil your fun. All right.
All right. Hey, everyone. I'm Sean. Julie couldn't make it today. But yeah, how's everyone feeling today? You feeling good? Yeah? Great. Well, I'm here today to talk about risk. So we've all been getting quite familiar with assessing risk lately. We all assess the risk in coming here today, or if you at home, maybe your employer assessed that risk for you. So what did you consider in deciding whether or not it was a risk worth taking? Was it data? Whose data? Was it recommendations from trusted experts, the media, opinions of your friends and family, or maybe you just had a gut feeling? Probably it was a mix of most of these things. And by the way, this is not the reason that Julie's not here, other reasons. So I want to talk about artificial intelligence and risk. I feel like we've been doing a good job in the larger library community of raising awareness around the possible unintended consequences of AI. But we don't have a lot of experience yet in assessing the shape and size of these risks for applying AI to our own projects. So I'm going to share some lessons that we've learned so far and a framework we've been building for evaluating AI for an ambitious project called the Audio Visual Metadata Platform. So Julie and I have been working together alongside all of these excellent people from Indiana, AVP, UT Austin and the New York Public Library on developing a pilot platform for collection managers to generate metadata for audiovisual materials through pipelines composed of both machine-driven and human components. We call these metadata generation mechanisms, or MGMs for short. So what this means is that we enable metadata enrichment workflows by piping together different AI tools with breakpoints in between for human review, editing, and workflow routing. In this example, a collection manager sends a batch of uncatalogued videos through a series of MGMs for speech silenced music detection, speech-to-text transcription, and finally, named entity recognition. At any point in the workflow, a human can review or edit the output with an internal or external tool. At the end of the process, the collection manager can download all of the outputs produced and use them to supplement their description and processing workflows. So the goal of this platform is to create a streamlined process that empowers collection managers to have some control over the outputs and accuracy of automated metadata generation through a user-friendly interface. And this is not the interface. We're working on the interface. But the AI tools themselves are packaged as modules that plug into the AMP platform, which is built on the open source Galaxy workflow engine. So these can be open source tools that you host yourself, like Tesseract for OCR, or Caldi for speech-to-text, or commercial cloud-based web services like AWS Transcribe and IBM Watson. Collection managers can then set input and output parameters for each MGM and view and edit the output in a human-readable format. So if you want to know more about the mechanics of the platform or Galaxy or any of the development, we've got lots of information on our project wiki, but I'm going to focus now on how we evaluate and select MGMs to include in the AMP platform, and how, if you're like Julie and I and you're not machine learning experts, you can assess MGMs for use in your own production workflows. So let's see. I should clarify the goal is not to solve any specific problem for a specific collection, or is it to find the best MGM for a given situation. We're trying to demonstrate how libraries can put AI tools into workflows. So what does that mean? So for this project, that means generating metadata that will go into catalog and metadata records or finding aids, or providing data that will help make description, archival processing, and rights clearance activities more efficient. To do this, we needed to start with real use cases, so it was important to get the humans who are mediating these activities involved in this process from the start. We already had a long list of possible MGMs generated from a previous AMP planning project, so Julie met with collection managers from IU Archives, IU School of Music Library, and NYPL to walk through some of their sample materials and to talk about what metadata would be useful to extract and how they would use it. Julie then identified common needs in order to prioritize the types of MGMs to incorporate into the project. For example, all the collections had some use case where they wanted to transcribe speech in a video or auto recording. And after that, each collection has some specific needs for each of their use cases. For instance, IU Archives was interested in identifying people and locations on campus. The Music Library wanted to identify works performed in concerts from supplemental concert programs. And NYPL wanted to identify discrete units of content or the absence of content on unprocessed videos to help speed up archival processing. So from this list, we were ready to evaluate open source and commercial candidates for each MGM category. But first, we needed to come up with some criteria for evaluation so that we could have productive conversations with the collection managers and the dev team about how each MGM will or won't fit our needs. So in addition to testing the accuracy of each MGM, we would need to consider factors such as cost, processing time, and computing resources needed. It was also very important to everyone on the team to consider the more social risks of MGMs, like how algorithms might express hidden biases, or what commercial services will do with the content you submit or the data they extract. So we included a criterion that we call social impact to assess what we found from each company's terms of service policies and potential risks that we saw in our accuracy testing. We found that fairness, accountability, and transparency in machine learning principles for accountable algorithms to be a guiding light in developing these criteria. And that's a long name. It's called FATML for short. So even though these were designed for developers of algorithms, they also provide a good assessment framework for organizations who are owning the responsibility of applying machine learning algorithms to their collections. For testing the accuracy of each MGM, we look to the FATML to guide our process, and we also look to existing library resources like the DLF metadata quality framework. The message from both of these frameworks is that before you can develop an approach to collecting metrics for assessing quality, you need to consider your local needs and users in defining what quality means. As a team, we developed a broad definition of metadata quality as it relates to our objectives. Note the emphasis here on good enough. So the actual measure of good enough for each of these functions will differ depending on the collection and MGM involved. So constant conversation with our collection managers during the testing of each MGM is important. For each MGM category you're testing, you want to consider the potential mistakes an MGM could make when applied to your particular collection and work with your collection managers to select samples that will draw out those potential errors, in addition to samples that are representative of the collection. For example, if you're concerned about a speech-to-text MGM misrepresenting certain spoken dialects, choose some samples with some distinctly non-Midwestern American accents. And we didn't learn this lesson until we got well into our testing, so if we could go back and do it over again, we would have been more thoughtful about how we selected our samples. Next, you want to determine what metric to use in testing the MGM performance. So at its simplest, AI predictions are assessed by comparing a ground truth of the ideal output against a sample of the actual output. In evaluating AI tests, we can use certain measures like precision and recall, F1 scores, and word error rate to get a quantitative picture of how well an MGM performs. I'm going to talk about precision and recall in a minute, but how you calculate any of these measures depends on what you need to assess. Let your use cases guide you. If you only want to get the list of words detected by a video OCR MGM, you don't need to measure how well it found those words at the right times in the video or on the right area of the frame. Your ground truth can simply be a list of words. Next, you'll create your ground truth for each of your samples. You'll run these samples through each candidate MGM you're testing, convert that output through to your ground truth format. You'll calculate your metrics, and then share your results out with your team for review. So I'm breezing through this part pretty quickly, but it is a bit time consuming and that you're usually gonna have to write scripts to convert your MGM output to a common format, and then write another script to run the comparisons against the ground truth. So there's not a lot I can say about this except that we've started putting all of our scripts and sample input output data into GitHub, so you can look and see for yourself what that entails. To show you how we scored precision and recall of the MGM output against the ground truth, I'm going to share an example from our named entity recognition testing, or NER, with this sample from NYPL's Gay Men's Health Crisis records. We ran the plain text transcript through 5 different NER tools to try to detect the names, organizations, locations, events, and topics that our collection managers identified as relevant. For each one, we created a confusion matrix to calculate the true positives, and false negatives in the MGM output. True positives are the entities that match terms in our ground truth. False positives are the entities the MGM identified that weren't in our ground truth. And false negatives are entities in our ground truth that weren't identified by the MGM. And we don't need to care about the true negatives here because there aren't any with this kind of test. Precision tells us how accurate our MGM was in matching up with our ground truth. High precision means the MGM did a good job of only matching with the ground truth without generating too many false positives. To calculate recall, we use this formula. Recall tells us how well the MGM did in finding as many true positives as possible, even if it also identifies a lot of false positives. F1 is a measure that strikes a balance between these two, and while it may be tempting to just use the F1 in comparing different tools or services, we can't trust any of these metrics alone to give us the whole picture of quality. So looking at the results from our NER, where we tested AWS Comprehend, Stanford NLP Core, IBM Watson Natural Language Understanding, the open source Spacey, and Google Natural Language API, we can see a very high precision score for Stanford and an excellent recall score for Google, but we need to dig into our true positives, and false negatives to get a better picture of quality and risk. Recall scores are useful to consider when there's a high cost associated with a false negative. For instance, if important entities like certain names or concepts are not recognized by the MGM. So even though Stanford scored high in precision and returned very few positives, false positives, its recall score was low because it actually didn't make that many matches. If we look at the number of true positives, it only found 38 out of a possible 112 entities. And it didn't detect concepts at all, so we didn't get important terms like AIDS, homophobia, or women's health. Looking at Google, however, we can see that it had very high recall, and it matched nearly 75% of the ground truth entities, but the precision was very poor. Precision is useful to look at when the risk of false positive is high. For instance, when we're especially concerned about an MGM labeling a term deemed inaccurate or even offensive. A low precision score means that the MGM may have generated many false positives, and in this case, we can see that Google did correctly identify 80 entities, but it also generated 737 false positives, which could mean a higher risk of terms we don't want in our metadata, or a higher cost in having a human review more terms than necessary. At this point, it's important to get collection managers involved in both calculating the kinds and size of risk associated with false positives or negatives, as well as assessing the costs and applying the right amount of human quality control needed to mitigate that risk. For the example we just saw, we are contemplating these questions with the collections managers now as we're reviewing the results from the workflow. This gets at analyzing not just what the MGM is producing, but what we can really do with that output to enhance discovery and access. If it's starting to seem like you're going to have to run ground truth accuracy tests on every collection and add a lot of human hand-holding in order to get good results, well, you're right. So even though this platform might look on the surface like a magical AI production factory that takes in unprocessed AV materials and spits out clean, complete metadata, at the start of this project, we recognized the need to slot in mechanisms for human interaction at any point in a pipeline. We're currently working on incorporating a number of existing open source tools into AMP for humans to review and edit the outputs in order to make this a useful platform for real production workflows. So I'll leave you with a few tips that we learned from this process, but I'm just about out of time, and the main takeaway here is that we tested all of these AI tools, but ultimately you also still have to. So I hope you'll find our scripts and evaluations helpful for that, and we'd love it if you could share back your own results with us and with the rest of the library community. Okay, thank you. I guess there's time for a question.
Yes, so you mentioned, or in your slide, you had Stanford. So I was just curious if you were able to tweak it so that it could look for things like people might say, our university, when they mean Stanford. So if you were able to adjust it for things like that.
We didn't for Stanford. We started looking at custom vocabularies for Spacey. Any of the other commercial services require a lot of context, so it requires a lot of training data. So we haven't been able to do that, but we did look at custom vocabularies for Spacey, but not Stanford because we had already ruled that out.
Thank you.
All right, thank you.
Up next, we have Stefano Kosu. Brace yourselves, the archives are coming.
Okay, all right. Do this business again, even if you don't need it. Go over here, the what's it? God, Windows, why are you the worst? Just make sure this is. All right. Okay. Thanks. Try one more thing just to make your life slightly simpler.
Can you just use the arrows?
Yeah, you can just use the arrows. I'm just making sure the arrows actually work when you hit them.
Cool. Hi, you almost made it. I'm Stefano from the Getty Trust. I'm a software architect, and I will be talking about implementing IIIF at scale at the Getty. Who is familiar with IIIF here? A few hands. I guess I can skip some of the introductions. Probably most of you know how useful IIIF is, and the Getty rebranded Getty recently, but it's hard to drop that in common speaking. Getty has having invested in IIIF recently. We joined the IIIF consortium, and the goal is to make IIIF a standard for all the images that we publish, and so we want to develop a standard set of tools and standard practices to produce and publish and deliver images to the public and internally as well. I was hired about almost a year and a half ago with the specific task of moving a couple of purpose-specific services based on IIIF, one for the Getty Research Institute, one for the museum, into a comprehensive architecture that delivers and handles all the IIIF images. This talk will focus on the GRI, the Getty Research Institute, which is one of the 4 programs, because the case study that I want to talk about is building the architecture for growth. The museum has a pretty sizable collection, but it's relatively static. The GRI acquires a lot of stuff continuously, so that's a particular challenge. A brief word about the GRI. It's a Getty program that's dedicated to the advancement of research technologies and methodologies in the cultural heritage field. It publishes some resources that might be well known to you, such as the Getty vocabularies and the provenance index. It runs a research library, and as I mentioned, it acquires a lot of stuff. So the refactoring of the IIIF architecture was engineered around the following points: central DL pipeline to pull all the data from different sources, mostly Rosetta and other sources. A shared store in S3 where we put all the images for all the programs, which requires creating opaque identifiers for the public. We don't want to leak or expose any internal meaningful identifiers to the public. We want them to be completely opaque, for which we had to build a crosswalk and an identity database. A scalable image server cluster to face the challenges of fluctuating traffic patterns, and an access gateway so that we can implement authorization and authentication in the near future. And of course, we want to know what's going on in our day-to-day life, in the day-to-day life of our servers. So we didn't want, coming from a previous experience of successes and failures in building large-scale software, I don't like looking at logs. I don't like sharing them with my stakeholders. So fortunately, the DevOps were already working on implementing Datadog institution-wide, so we are using Datadog for log analysis and monitoring, which is very useful. This refactoring took about 6 months of research and design, and I explain why it took so long. And it took about 10 months of implementation for the first phase, which includes only open access images from the museum and one project of the GRI. In total, about 300,000 images. And the resources were fairly limited, was 1.5 FTE, including me. And the great success of it is the users didn't notice anything when we switched sources. So for a backend system guy, it's a big thing. Why did we do this if nobody noticed anything? It's because of the projected load of information that we will receive. I try to spend not too much time on this slide, which I love. Ed Ruscha is an iconic Los Angeles conceptual artist who spent several decades with a motorized camera on a truck, running back and forth on Los Angeles streets, most notably Sunset Boulevard, taking pictures of every single building back and forth. So he has this huge archive of images. Not only he did that for the whole street, but he did that in several years. So we have actually a layering of images that document how the streets changed over time. So it's a very important historical and artistic document, and we acquired the whole thing. So we have 150,000 images that have a huge potential in the digital world, and we want to build applications with it. This screenshot on the left is an yet to be published interactive app where you can actually drive this little truck that was Ed Ruscha's truck along Sunset Boulevard, and the images zoom back and forth in front of you. And you can imagine how that could open a deluge of images in users' browsers. You can run about thousands of images per minute for every single user. So we want to make sure that we're prepared for that. The next project that we are working on is Phototech. It's about 700,000 images from different contributing institutions that reproduce artworks, and it's part of the Getty Provenance Index. We want to build provenance around artworks, so scanning and digitizing these physical cards that represent artworks over course of time is a very important part of this provenance index. There are 700,000 of them, so this is going to be next step up in terms of volume. And the big thing coming will be this, the Johnson Archive. You probably heard that the Johnson Publishing Company filed bankruptcy last year. It's the publishing company behind Jet and Ebony Magazine. It represents a monumental document of African American culture for the 20th century. And the Getty, the Smithsonian Institution, and some other institutions that I now forget just bought the whole archive, which consists of 5 million items, not images. We don't know how many images are in the items, so it's going to be fun. It's not going to come for several years because I sympathize with the rights and reproduction team, which has to do all the hard work to scan through all the stuff. But it's probably going to take a few years, but we got to be ready for it because this is going to basically put in question every single part of our IT infrastructure. So we can see a pattern here. We have a scale in traffic, in volume, and in features, meaning that applications that are used that we can build upon this information. On top of it, we have challenges related to complexity. We have different sources. We have the quality of the contents and the metadata can change, and we can have different access patterns where you can have restricted or public images, images that need resizing because they have rights limitations, and so on. So how did we approach all these challenges? The first thing that I did when I came on board and was assigned this project was to run a report. I I gathered all the available server softwares that were, that handle IIIF images, and made, different benchmarks with different combinations of image qualities and sizes, and so on. And this report is available at this link if you're interested in seeing the report, and the link actually is a Google folder that also has the source materials and the code, so you can, in theory, reproduce the benchmarks. For content processing, ETL was a critical part of it, and we built an in-house ETL framework that I wanted to be very solid, because we know that it would be very heavily threaded. We built a really simple UI for sharing the result of ETL tasks, which is very important when something goes wrong, or even when something goes well, and you want to tell the content managers, hey, we have these errors broken down by this type. This looks like a data type. Please look at it, and it's very transparent. So we want to actually enable non-IT staff to help us help them fix their data. Quality control is where I get less nice to people, and I actually get to demand some very specific parameters. And it's more of a accountability topic than an IT not wanting to do certain things topic. It's, I don't think IT, for example, as the qualification is qualified for assessing the quality of an image. That's imaging. We can't tell if an image has the right profile. We can't strip an alpha channel automatically because we don't know how the results will be. So that's where we need to be very strict and say, actually have a written document that says, the images that we receive have to be, this color model, that they don't have to have alpha channels or layers or other stuff, and so on. That makes things much clearer, a little more work upstream, but a lot less work downstream. Same thing with metadata. Most critically, we don't want to infer access policies. We want the access policies to be in the systems of record, and we want to receive very clear and explicit access policies, so we don't have to make up things, and when things go wrong, we know where to look at. And finally, automation is, of course, very welcome when you're talking about large scale, but also we want to make sure that we know where and how to automate. My personal approach is to maintain a naive approach to resolving problems, and then scaling up if that naive approach results to limited. For example, we use activity streams to receive information about updated records, and so far a cron job like polling method has been perfectly fine. We have seen no problems with that, also because ETL is not a time-critical task. When we ask for changes, the only thing that I care about is identifiers. I don't care if the record has changed or has been created or has been deleted. I'm going to ask the source at the moment that I'm making the transformation. If I find the record, it means that it's either been unpublished or deleted, so I'm going to delete it downstream if it exists. If I find it, I get the data and create or update downstream. Also, this removes all possible complications and race conditions, and it's been working so far. Auto-scaling, we are deploying on AWS Code Build, which can get very complex and very powerful. So we don't want to get overwhelmed by the power of this tool, and we want to run some profiling of our applications before we deploy something that is extremely scalable and flexible, but also extremely complex to set up and maintain. And that's it. If you have any questions, I'll be happy to take them. Thank you. Thanks.
I'll do the thing. You would think.
Yeah, in the perfect world.
What's your thing called again? Wait.
Yeah, you had it.
Wait, this one?
Yeah.
Oh, okay, all right. All right, I need the thing on the thing again. Oh, there it is, thank you.
Slow slide.
Because it reaches the end of the trackpad and then it goes, you know. No, I don't want to spoil it. Okay.
All right, cool. Thanks. Sure.
All right, for our final talk for today, for the Code4Lib conference overall, we have Vicki Steves, Genevieve Milliken, Sarah Nguyen. Let's talk Git, investigating and archiving the scholarly Git experience. Easy for me to say.
Thank you. Hi, everybody. How's it going? Thanks for letting us headline, or as Ruth Tillman said, footnote Code4Lib. You know, as we were introduced, I'm Vicki Steves. Behind me are Genevieve and Sarah, and we are part of the Ice Age project. LB is one of our mascots of the three. Whoop, shout out to LB. So who are we? I'm going to give a little bit of an overview of the project. So we're NYU's Division of Libraries. In addition to us, the folks on the Digital Library Technology Services are a really core part of this project, which we're calling Ice Age, even though the acronym doesn't exactly line up. So Ice Age is basically, it's a Sloan-funded project that has two key streams of work. So the first, which Sarah's going to be talking about, is a behavioral study of how folks in academia are using Git, so the source control program, and Git hosting platforms, and how these tools could be better aligned for academic purposes. As we know, teaching folks these tools are really difficult, or as a lot of us know, and from our own experience. And then Genevieve is going to be talking about approaches to archiving the scholarship that exists on Git hosting platforms in the Git data format. So we're hoping that the results of this project can help all of you in your processes to take basically really active, ongoing collaboration with code and move it to a stable, permanently citable, active preservation environment. So just to be clear, I assume everyone in the room knows what Git is, but just in case, Git is what's called a revision control system. So that's basically a way to let us compare, restore, go back in time, you know, merge changes to our plain text stuff. So that's like code, text, some images, SVG, really good with Git. And it's a command line tool. What we're calling Git hosting platforms are basically places on the web where you can upload a copy of a Git repository, the most popular obviously being GitHub, which was mentioned several times. But we're also looking at GitLab, Bitbucket, SourceForge. There's a big list on Wikipedia, which is where that slide comes from. And since we're talking about specifically scholarly Git usage, I thought I'd just give a few examples before Sarah digs deeper into that. So the screenshot of the repository is from the Journal of Open Source Software, which hopefully a lot of you are familiar with. If not, I highly recommend it. Probably a lot of your scholarship would be really good candidates to submit to JOS, so I recommend you do that too. They run their entire journal infrastructure off GitHub. They do the peer reviews via issue threads. They build their website using continuous integration. They're really great. So that is one example of what we're calling scholarly Git usage. The other would be sort of what you think about, publishing code as supplementary materials. And then at the bottom, at the other side, is this great figure from a preprint on bioRxiv. Just basically details how this wet lab was using GitHub and Travis in conjunction to do some data processing. So before it gets to the analysis stage, checking things like, are all the columns well formed? Are all of the values aligned correctly? It's a wonderful preprint, I highly recommend it. So these folks don't just cover computer science. In fact, computer science is a really tiny wedge in this pie chart. This is another really great preprint from Hasselbring, which estimates that there are about 5,000 GitHub-specific repositories that are identified as scholarly, mostly coming from life sciences, in fact. So it's really interesting in that they found basically 1,200 GitHub repositories from a DOI, so that thinks about the integration with Zenodo and some other approaches that Genevieve's going to talk about, and then others that are explicitly cited in scholarship. So this figure comes from some really interesting research done across scholarly lit. So the problem we want to solve is basically researchers are using a lot of these tools that link up for development purposes. There is a lot of contextual ephemera that we're calling scholarly ephemera. So that's like issues, threads, merge requests, things like that. And no project is currently capturing both the source code and the ephemera. And so this is where we sort of want to bridge that gap. The elephant in the room is obviously GitHub's archiving program. I'm not going to say too much about it, but you should read David Rosenthal's Takedown. He details what it would take to basically get to the Arctic in the event of an apocalypse, which is where all the source code for GitHub's archiving program is going. So with that, I'll pass it to Sarah, who's going to talk a bit through our behavioral part of the study.
Hello, my name is Sarah. I am studying the gap analysis to understand scholars using Git in this project. So it's more understanding of how they use the features and integrated into their workflow. And this is Henry and Ty looking at the gap. So my research is broken up into 5 different parts. It starts with a literature review of just understanding who has referenced Git and where have they talked about using Git or Git hosting platforms in their research. Then it goes into a systematic review, which I'll go into more detail, a focus group, broad survey, and user experience interview. So you can see that we're trying to really go in depth of understanding what is the behavior before we actually build our program around preserving. The literature review, where I'm asking questions around how can features in Git and Git hosting platforms serve scholarship? How are scholars currently using this toolkit, the features within it, issues, wikis, and how can we improve teaching Git for minimal users? We're defining minimal users as those who have been introduced to Git and Git hosting platforms, but hasn't actually integrated it fully into their research workflow just because of a lot of the barriers that we see, because it's not as easy as we know it to be in use. And then all of the, kind of like an update on a lot of our ongoing research is on our blog, which is linked here, and you can check it out. We try to come out with something at least once a month, but you know, life. In the literature review, there are a few different Git experiences that I found within, obviously, version control, as that is what is natural to Git. Community and collaboration, that's crucial to scholarship as we cite and reference each other's work. Method tracking has been popular within lab notebooks, and then just kind of like departmental types of what are they doing and like what are the protocols. Education, I'm not sure if any of you have used GitHub Classroom or any of the other Git hosting platforms. They like to use it for teaching. Data processing, reproducibility, and publishing. These are also all ways that a lot of researchers have referenced within either a blog post or within their articles of how they integrated it, whether it's within humanities or within the hard sciences. So part 1 is a systematic review. This has been an ongoing process just because harvesting data from websites is obviously a difficult thing, especially if you're working with Google Scholar, who kicks you out if you're trying to grab stuff from them. So essentially, we're trying to look for articles that have referenced github.com, gitlab.com within any part of their full text, just so that we can understand the landscape of how many people and how often, or has there been an increase through time of people referencing Git or Git hosting platforms in their research. Yeah. Oh, I should also say, since Google Scholar has been kind of difficult to harvest, we are also looking at other journal repositories. We are considering Sci-Hub as a research tool. Happy to talk to that with anyone if you have any ideas or approaches to that or what you think about that. Have not done it yet, but we're definitely interested in hearing any sort of legalities around that. The second part is the focus group. It's a qualitative approach to understanding just how users have learned or been introduced to Git and Git hosting platforms. So what we're doing is grabbing a bunch of students who have taken class from NYU Library's Introduction to Git and GitHub class, and we're going to ask them a bunch of questions of just how they have approached Git after they've learned it. A lot of the teachers who have taught this type of introduction to Git have found that students are excited once they're in the class, but then once they actually start bunkering down to using it within their research, it's been difficult to include version control systems. All the Git commands kind of get confusing for them, and then they also just have to end up starting over. So yeah, we'll see how that one goes. We're having our first focus group later this week, and we'll see how that goes. One of the difficult parts of gathering the focus group participants has been, what we see is, we're not sure if people feel confident to actually talk about it, especially since, within learning technology, it's kind of just difficult to say that I don't know how to do this, even though I've taken this class, especially if they are PhD students, graduate students. So that's been a bit of a roadblock. But these are the types of questions that we're asking them, exploratory questions such as, what do you look for in tools to manage your research materials? Do you actually use Git in your current workflow? And then we are wrapping it up just to see if they have any other ideas of how they've approached source code management and any other Git hosting platforms. Then it goes into a broad survey, which is another quantitative approach. So you can see that we're going with a mixed method here. Our target population are Git users across all disciplines and across all types of statuses, whether they are a faculty member, a researcher, an undergrad, or a graduate. We also are looking to get people who have from the minimal user to an advanced user. So all of you should participate in this survey. Keep an eye out for this survey when it comes out in the next coming months, and please share widely. These are the types of themes that we're looking for, beginning from how you have learned Git, do you teach others Git, what is your daily use? So hopefully it's not too long of a survey, but we would really appreciate your participation. Part 4, and the last part, is the user experience interviews. This is really sitting down with someone who uses, or who's a minimal user using Git, and to see how do they actually click through the program or actually use through the command line, and where are there roadblocks. And then this will also inform us if we need to improve our teaching within Git, and how can we actually make it easier while we preserve it and make it accessible to them. And then all of this is to say that it'll lead to a gap analysis of understanding the entire workload of Git and Git hosting platforms as scholars use them. So now I'm going to pass it over to Genevieve Milliken.
Hi, I'm Genevieve Milliken. This is my cat, Oshi. She's very cute. She's been researching all day. Let's see. So in parallel with the research that Sarah is doing, we've also been working on an extensive environmental scan that focuses on 4 distinct areas of inquiry and is designed to review current ideas regarding how source code and its contextual scholarly ephemera can be archived and preserved for reuse. The 4 areas of our study include web archiving, self-archiving, programmatic captures, and software preservation. We chose these topics in particular because of their larger contributions to digital preservation efforts, as well as their usefulness in capturing not only source code repositories, but also the contextual ephemera that help us, as well as future researchers, understand a repository's development history and associated documentation. We were motivated to study web archiving because of the contributions that the web archiving community has provided to the larger digital preservation landscape. In particular, we wanted to understand which web archiving tools were available to us and to see how these tools would perform when adapted to capturing software repositories on Git hosting platforms. During the research process, we were able to identify tools that were common in GLAM institutions, as well as other ones that took advantage of the underlying architecture of web-based repositories. If you think of a GitHub repository or my GitHub repository compared to your GitHub repository, it's going to have different content on it, but the overall layout is going to be the same. So the specific projects that we were interested in were Archivit by the Internet Archive, Web Recorder, and Memento Tracer, all of which we'll be talking about momentarily in our tool testing phase. Our second area of the environmental scan is self-archiving. Self-archiving is simply the act of self-depositing research in a general, subject, or institutional repository. In particular, we were interested in the different motivations researchers might have for depositing content, especially code in general repositories. In particular, are they doing it because they want to be transparent in their research, or are they mandated by a grant? And this includes the Zenodo and the Open Science Framework. And we wanted to understand the appeal of these general repositories when compared to perhaps an older institutional repository. For source code, these types of investigations can be a bit tricky because many repositories were built to host, describe, and make findable manuscript and text-based files. They were not necessarily designed to do the same for complex digital objects. In terms of general repositories, we really wanted to understand the flexibility of some of these platforms. I think there were some tweets about Invenio, so perhaps we can look at that with their feasibility of hosting data and software a little bit better. So some of this included handling versioning, minting DOIs, and overall ease of use, and including the integrations between platforms. I'm sure many of you have used the integration between Zenodo and GitHub, which allows you to push a version and get a new minted DOI. Okay. And this includes the Open Science Framework and their suite of tools that they link with. For programmatic captures, we were interested in researching organizations that are currently archiving Git hosting platforms at scale. If any of you are familiar with the software heritage, they're certainly doing some impressive works in this area. They currently have a full copy of many Git hosting platforms, including GitHub, and a lot of the platforms that have been censored over the years, like Google Code. They've also contributed to scholarship on software citation and have made many inroads for archiving and referencing source code in academia by using intrinsic identifiers that are comparable with Git commit hashes in their archive. Further, we were also studying large-scale mining of GitHub API data. So this is all of the content that surrounds a repository's activity. This includes GH archive and GH torrent, which make use of the event data and make it available in a queryable form. While software heritage, GH archive, and GH torrent are focused on large-scale captures of repositories or contextual information about the repositories through the GitHub API, there are also other projects that are specifically centered on curation and capture of research repositories in academia. This includes SARA, the software archiving of research artifacts, which is a really cool project that allows you to send your GitHub URL or GitLab URL and clones a copy of it to an institutional instance of GitLab, and then also the metadata is pushed to a DSpace. As you have noticed, my job as a researcher is to study the people and projects dedicated to long-term repository archiving. My work and the work of the team is to foreground source code as a valid scholarly output and to treat it as an index of intellectual labor worthy of citation. This working model or praxis will hopefully allow us to build relationships with researchers and to place software within the broader scholarly ecosystem. With that said, all of this work will inform an archival specification that can be adopted by institutions looking to capture and preserve software-based repositories. This specification will include recommendations for capturing software and scholarly ephemera, descriptions, and curation informed by software preservation best practices, and sample preservation workflows. And in addition to our environmental scan, we've also been doing some web archiving tool testing. We tested Archivit and Web Recorder and Memento Tracer. Our Archivit testing or test crawls were pretty successful. We tested 4 repositories that I scraped from JOS. And GitHub and SourceForge did really, really well. I was happy with the captures, but unfortunately GitLab and Bitbucket will need some more investigation, including patch crawling and some work on the scoping rules. Web Recorder, if you've ever used it before, has a really high fidelity, captures really well, and it captures dynamic content in JavaScript, but it can take a long time. And currently they have a feature called Autopilot, which gets nested content. If you think of Twitter, it'll capture the tweet, but also any comments and pictures, so it automatically captures the nested content. It's pretty impressive stuff. But unfortunately, there's not one for GitHub at the moment. And lastly, Memento Tracer. The Memento Tracer people at Los Alamos Labs, big shout out to Martin Klein. He's been a really big supporter of our project, and we really appreciate his support. And so Memento Tracer, they actually use a Chrome plugin that creates a JSON trace for the content that you want. So say if I want, see at the screenshot, I want all of the links on the sidebar. It's where like all of the content for the repository sits. You can create a JSON trace to say, I want all of these links in this area. And then that information is translated into instructions, into JSON, and then you use the Memento tracer. They currently have a demo crawler. So you feed the JSON and the crawler, you feed the URL and the JSON, and you capture the information. And what's really cool about it is that JSON trace is not wed to the website that I created it on. So with that, I will pass it back to Vicki to wrap us up.
Yeah, so we have a few little summaries and call to actions. So basically to sum up everything that we've been saying, code and its contextual ephemera are worth saving. There's a lot of scholarship in the Git data format and on these Git hosting platforms that are really at risk. We want to understand behavior patterns to help us in our archiving and teaching and learning work, and we also want to uncover the highest fidelity ways to capture this work. So be on the lookout for our research-centered posts, which are on our blog. Send us any feedback or resources, anything you feel that we should be looking at. Feel free to tweet or toot at us if you're on Mastodon. And that's what we got. So we have 25 seconds left if anyone has a question. Thank you very much. Oh, okay. 10, 9, 8. Just kidding. Yes.
Yeah, Vicki, thank you all for an awesome presentation. I was really looking forward to this, and it was even better than I figured it would be, so well done. Really quick, because I'm a weirdo who doesn't use Git but uses Mercurial, what about other version control systems?
Yeah, this was when we were scoping out this project originally. We were basically looking at what would be effective for the widest amount of people. And sorry, but Mercurial lost to Git in that respect. Furthermore, a lot of Git hosting platforms are sunsetting support for Mercurial, like Bitbucket was the latest one. So unfortunately, unless you're on, I think it's like Coburg or you're self-hosting Gitty or Gogs, you're gonna be losing some of your options for hosting your Mercurial repositories. So, yeah, sorry.
Yeah, you mentioned a survey was going to be coming out fairly soon, and in my notes I missed how to get connected to that. Could you just plug that one more time for me?
Yeah, so it's not out yet, but when it is, we're going to be sending it around to lots of lists, like the Code4Lib list, all over Twitter, I'm sure, so we'll make sure it gets to this group.
We'll post it on our blog, so if you follow our RSS, it'll be on there.
RSS is not dead.
Long live RSS.
Anything else? All right, get in touch. We're an approachable group. Thanks very much. Thank you.
Wow, and just like that, we've come to the end of another Code4Lib. Before we go, just a few thank yous. Let me get to this real quick, and we'll let you go. 1 second. Dre's supposed to be doing this. No, I'm kidding. I got it right here. All right, so without the contributions of lots of people, including sponsors and volunteers and our conference planners, none of this would be possible. So we want to give out some thank yous. First to our sponsors, our diamond sponsor, Blacklight, platinum sponsor, EBSCO, gold sponsor, Carnegie Mellon University Libraries. Not biased at all. For more gold sponsors, OCLC, our sponsor for streaming video, real-time transcription, and closed captioning. Our silver sponsor, Senator John Hines History Center. Bronze sponsors, the University of Illinois at Urbana-Champaign School of Information Sciences, Index Data, Atlas Systems, Rutgers School of Communication and Information, Lyrasis, Ex Libris, our sponsor for transportation, John Hopkins Sheridan Libraries, our sponsor for childcare, and Equinox Open Library Initiative. contributors, Temple University. And we also want to thank our wonderful, wonderful conference planners, Jennifer Cummings and Kathy Azevedo from Concentra. They are fantastic. Let's hear it for them. Wow, it wouldn't be possible without them. Yes, indeed. And our Code4Lib volunteers, including committee chairs, website working group, Eric Pettiplace does a fantastic job. But budget, Galen Charlton, sponsorship committee, Mary Jingoeski. All right, I got it. Keynote, Clara Turp. Pre-conference committee, Jason Glenn and Anne-Marie Mesco from Carnegie Mellon University Libraries. Program committee, well, that was a committee by committee. We didn't really have a chair, but Dre as always does a lot of work. So scholarship committee, Carnegie Mellon's Jessica Benner and also Yi Ding. Great job with scholarship committee. T-shirt committee, there was no official chair, but Emily Wall helped us tons. So shout out to Emily, who wasn't even on the committee, who really, really helped us. She's fantastic. On-site volunteer committee chair, Ken Rose. Yep, I just penciled myself in there, okay. Social activities chair, Becky Hughes. She's fantastic, even from afar. Accessibility committee chair, Kate Dybel. And whatever committee chair, we didn't have any. And again, for fear of repeating myself, a big shout out to Peter Murray and the AV team for all they did to make this wonderful. Seriously, guys, that was fantastic work. Fantastic work. So we are at the end here. I just want everybody to get home safely, wash your hands early and often, and let's put the band back together next year. Great job, guys.